Hi there everyone. This video here we're going to talk about areas underneath curves and extend the ideas that looked at in the last movie, which was kind of going through the theory behind it. So let's get into some questions that are like you will see in tests and exams. So this question here asks us about finding the area between the curve and the x-axis between different x values. Now the important thing to know here is that if we want to know the area between 0 and 3, that's this bit here, that's really easy. The integral from 3 to 0 of the function, not a problem, really easy. The tricky bit here is when we start dealing with areas underneath the curve. So when we're working out the area between 3 and 4, which is this area, the value that our calculator is going to spit out is going to be negative. And that's a really important thing that we have to understand for this thing here. So when we do the integral, or we want to find the area between 0 and 4, area is always positive. We can't say area is negative. That doesn't make sense. So if we just do the integral from 4 to 0 of this function here, and do the antiderivative, substitute 4 in, substitute 0 in, we will get the completely wrong answer. And there's a reason for that. The reason is that the formula will calculate this area here as being positive, this area here as negative, and it'll add those two together. So let's say if this area here was 2, this area here was 1, this calculation here would say 2 minus 1 and tell us that the area was 1. The area, total area, is clearly 3. 2 above, 1 below, total 3 area. But we'll get the wrong answer if we just plug it into our calculator just like that. So using our graphics calculator here, drawing the graph, having a look, understanding the areas below the curve are negative are really key if you want to get the answers right for these ones here. Okay. So here's the answer to A for this one. The area is going to be the integral from 3 to 0 of 3x minus x squared dx. Okay, so we do the antiderivative, which looks like that, and we want to work out the area between 3 and 0. Okay, that's how we write that. It shows that we've done the antiderivative. I do the square brackets and the limits of the integration here in this definite integral, top and bottom. So that is going to be, now we substitute 3 in, and then we subtract and we substitute 0 in. Now I think you can see pretty clearly if I substitute 0 into there, I'm going to get 0. So we get our calculator out, that's going to be 3 squared, 27 over 2 plus 27 over 3, and that works out to be, let me work that out, 4.5. So in this case, 4.5 units squared. Okay. For part B, the integral from 4 to 3 of 3x minus x squared dx is going to look really similar. It's going to be the same integral. Between 4 and 3. This one's going to take a bit more work because I have to substitute 4 in there, subtract, then substitute 3 in there, and you will get negative 11 over 6. So that's definitely something that you want to do on your calculator. Okay, so the answer to part C, as I've said, it would be wrong to just do this. Okay, if you just work that out, you're going to get the wrong answer. What you'll get is 4.5 minus 11 over 6, which is wrong. So what we really want is not the integral, but the area. That's what the question asks. What is the area between the curve and the axis from 0 to 4? So we've got this top area here. We know that's 4.5. We know that the area, the answer to this one here, is 11 over 6. So the total area is we just add those two together. And again, calculator comes in handy here. And I'm totally cheating, and it gives you 6 and 1/3 units squared. a really cool thing here is on your calculator, you can overcome all of that, having to know whether it's on top, whether it's on bottom. You can overcome all of that if you just use these absolute value signs when you put that in on your calculator. So using your calculator here, just use the absolute value signs, not a problem. You're going to get it right every time, which is really, really great. Okay, some quick examples here on areas between curves now. I think, again, this is pretty obvious. If you want the area underneath, between these two curves here, what we do is just work out the area underneath the top one, work out the area underneath the bottom one, and subtract those two areas. Hopefully you can see you then get this shaded area here. So that's the technique we're going to use. We're just going to say it's the integral of the top one minus the integral of the bottom one. And that's the formula for finding the area between two curves. Again, you might have really kind of funky things going on where one curve does this and another curve does that, and you've got this bit at the top and this bit at the bottom, and they kind of swap over and you're not sure which one's on top, which one's on the bottom. Again, if you use the absolute value signs on your calculator, you'll get it right, and it doesn't matter which one's on top and which one's on the bottom. Okay, so that's important on your calculator. Use those modulus or absolute value signs. So one example here, the area enclosed between these two curves. Really good idea to draw them if you can. So again, on your calculator, it makes it really easy. So y equals 2x squared is a parabola that just touches the x-axis there, and 12 minus x squared has a y-intercept of 12, and it's a bit wider than the other one, and it's an upside down. So we are trying to calculate that thing in there, so it's going to be 12. Now we need the limits of the integration here, so we need to know what these two x values are. I can see from my sketch that there's a symmetry there, so whatever this x value is here, this one will just be negative of that x value, so that's going to help us. So by hand, first of all, we need to discover this. When are those two equal to each other? Okay, so let's go ahead and solve that. Squared is 4, so x is plus or minus 2, so that one's 2 and that one is negative 2. So now I can write the answer. The area between those curves is the integral between 2 and negative 2 of 12 minus x squared take 2x squared dx. Just means we're doing this all with respect to the variable x. Okay, I'm going to do some tricky stuff here, because I'm going to say that firstly we can make this a lot easier by saying that this is double the integral from 2 to 0. So in other words, what I'm saying is that this area and this area are the same, therefore I'm just going to calculate this area over here on the right and double it. And this only can happen because of the symmetry. We've got 12 minus x squared, 2x squared, so areas are symmetrical. Okay, and a little bit of simplifying here. 12 minus x squared minus 2x squared is actually 12 minus 3x squared. So we can do some algebraic simplifications there, which makes life easier, so we don't have to integrate so many terms. Okay, and so now we're on our way. We do the integral, or the antiderivative. 3x cubed over 3 is just x cubed, and we're going between 2 and 0. So we substitute 2 in. It's really important that you write this step really carefully, guys. Don't skip any of these steps. Okay, so 2 times 24 minus 8. 24 minus 8 is 16. So that is 32. So that is 32 units squared is the area between those two curves. Now, as you can appreciate, the application here is any kind of printing, industrial kind of cutouts of shapes are done using computers these days. So you might want to get a certain area for a certain shape that you need for it could be a ship, it could be a boat, it could be an airplane, anything like that, and you might want to know the exact amount of area that you need that's got to cover. So you know you're going to use mathematics to model the kind of shape, and this shape you can see you can end up with is quite an interesting shape, which is exactly 32 units squared. That's the exact area of that shape.